Welcome you all to this video session of lecture for geothermal energy, and it comes under module 5. In this session, we'll understand what is geothermal energy, what are the different types of geothermal energy, what are the applications of geothermal energy, and also we'll understand where we find the geothermal energy. Geothermal energy. Geothermal energy is the energy that comes out from the Earth interior surface. It may be in the form of heat, it may be in the form of volcanoes, hot spring, geysers. We might have noticed or we might have come across in the some of the river or near to the temples, if there is a river, and we'll get a hot water, and people tell a hot water bath, we can take a hot water dip over there. That is nothing but hot spring, and this is also coming from the earth interior surface. The earth center is a distance approximately 4,000 miles and is so hot that is in the form of molten state, because uh, in the earth crust it cannot be in the form of liquid, so it is in the form of a molten state. Temperatures are understood to be around 5,000 degrees centigrade at that center. The heat from the center of the earth conducts outward and heats up the outer layer of the rock, and that is called as a mantle. When this type of rock melts and becomes molten, it is called as magma. In the sketch, you can see the geothermal energy. First figure on the left, you can see the practical geothermal energy, how it is utilized, and on your right you can see what is the working principle that is adopted in the geothermal energy. If you can see the sketch over here, the hot water which is coming from the earth interior surface, when it comes to the earth surface, it will be in the form of steam, and this steam is used to run the turbine. Here, of course, it should be a steam turbine, because the hot water, when flashes from the interior surface to the different atmosphere, it will be in the form of steam, and this steam is made to propel the turbine, and this turbine is connected with the generator, and of course this turbine, after working, that hot or the left out is sent to the cooling tower or a condenser, and where it rejects the heat, and the cold one is once again injected through well to the interior surface. So in this way the water is conserved in this application. Magma can reach just below the earth's surface. Rainwater sometimes seeps down through the geological fault lines and cracks, becoming superheated by the hot rock below. Sometimes this superheated water rises back to the surface of the earth, and we know that the superheated steam, the drainage fraction X is always 1, but when it comes to the saturated steam, we may have the range from 0 to 1. So the superheated steam are always liked, or it is essential that we'll get a superheated steam to drive the turbine. Where it emerges as a hot spring or even geysers, sometimes the hot water becomes trapped below the surface as a geothermal reservoir. Although the amount of heat within the earth is large, useful geothermal energy is limited to a certain sites only, and those areas are called as geothermal field. Wherever I get hot water, I cannot consider as a geothermal field. So, which is having some useful energy and it can be utilized effectively, those fields are called as a geothermal field. On an average, the earth emits 1 by 16 watt per meter square. However, this number can be much higher in the area such as a region near to volcanoes, hot springs, etc. So, but on an average we can tell it is of a 1 by 16 watt per meter square. As a rough rule, we can see 1 kilometer cube of hot water is cooled by 100 degrees centigrade with a yield of 30 megawatt of electricity over 30 years. It is estimated that world would produce around 6 lakhs EJ over 5 million years. So much joules of heat that can be produced per over a 5 million years. There is believed that to have enough heat radiating from the center of the earth to fulfill human energy demand for the remainder of biosphere lifetime. The total estimation is around 2.11 into 10 to the power 5 joule, which is enough for supplying next 3 lakh 50,000 years. So a huge amount has been estimated. As for the geological survey, earth crust up to depth of 10 kilometer above 15 degrees centigrade is defined as geothermal resource. The adjective geothermal originate from the Greek root that is the meaning of earth, and thermos means the meaning of hot. What are the different applications? Let us see the applications. As we already discussed, one way of producing electricity from the geothermal energy is by drilling wells into the geothermal reservoirs. The hot water that rises on the surface is in the form of steam. Because of flashing, we have seen, right? Because there is a difference in the pressure of the earth crust and atmosphere when the hot material or hot fluid which is coming from the earth surface, when it comes, it will be flashing as a steam. The steam is used to drive turbine producing electricity. If the water is not enough to produce steam, it can still be used to heat homes and business, saving gas or electricity. The geothermal energy is relatively environmentally friendly, right? It is not going to like the conventional one. It is not going to have any bad effect or on the pollution or the fossil fuel having other disadvantages. Unlike wind power, geothermal power can be relied as it provides constant power. When we talk the wind power, it depends on many factors like the velocity of the air, right, and the area. And we also seen in the when it is a wind plant, when power plants are installed, there is a migration of the plant, and it gives a very bad impact on the birds, right? It gives a wrong direction for birds, and moreover, the noise also a bigger factor, which is a disadvantage with respect to the wind power. Those disadvantages surely is not there in the geothermal energy. The temperature, if it is between 50 to 57 degrees centigrade, it is used as a low grade energy for direct heat utilization like food drying, water heating, chemical, textile process, washing, warming fish pond. So these are the things. So the food drying, they want the temperature around 60 degrees centigrade, and for taking the bath, we want the water that is around 50 to 60 degree. And the chemical or textile industry, where the yarn or the pulp has to be done, where it is to be soaked, this temperature is enough. And washing, for the washing the clothes or washing the utensils, generally 60 degrees is enough, even for warming the fish pond. The next one, if it is a temperature is in the range of 90 to 350 degrees centigrade, means somewhere it is sure in the superheated state, that steam which is used can be used for the power production from the turbine. The plant are used as a base load plant. These are cannot be used as a peak load plant because of the scale and corrosion problem, right? So whenever this we are using, uh, the main problem comes is the water is untreated. It may be having some impurities, right? And since we are not doing any treatment over here, like the river water treatment, in case of conventional boilers, so it may lead to the corrosion problem. So it cannot be used for the peak load plants. The Let us see what are the comparison with the conventional plant. Less temperature and pressure as compared to conventional. As a result, the efficiency is about 15%. The condenser used in the conventional are indirect contact. What is direct contact? Direct contact means the two fluids are in mixing each other, means like a deaerator, right? The deaerator is heat exchanger, which is a direct contact, where the steam and water comes in a contact with each other. But here in indirect contact, the two fluids will not mix each other, means it is a shell and tube. One fluid is moving in the tube, other fluid is surrounding a tube. So these type of condenser are used in the ATAC system is a direct contact, where two fluids are mixing. The makeup water, so makeup water has is external source of conventional system, but not in a ATAC system. One more point is when I'm mixing the two fluid together, the main parameter, that is a heat transfer coefficient, will be at a higher range. Therefore, it is always preferred to have the direct contact one. The fourth point is steam will not mix with the non-condensable gases in conventional plant. So steam is not going to mix. It means the particulate matter or the oxygen, right, will be very less in case of a steam in the conventional plant. But here the particular matter of the oxygen may be there. That is a one uh, drawback of this system. Let us see what are dry steam or vapor dominated steam plant. These are one category of the steam plant. in the geothermal system. Steam is extracted from the well, cleaned in a centrifugal separator. The centrifugal separator works on the density difference, right? And it removes the solid matter and then piped directly to the turbine. The exhaust steam of the turbine is condensed in a direct contact condenser, in which the steam is condensed by direct contact cooling water. The resulting warm water is circulated and cooled in a cooling tower and returned to the condenser. The condensation of steam consequently increases the volume of cooling water. Excess water is re-injected at some distance deep into the ground disposal. The non-condensable gases are removed from the condenser by steam jet ejection. So in this sketch you can see the production well from where the hot water comes, and because when it comes to on the earth surface, right, it is in the form of a steam because of change of phase, and it propels the turbine, and the water is directly injected into the well after it's worked in a some stage or a single stage of the turbine. It is since the turbine is coupled with the alternator, and we will get the load, and here the water is re-injected into the earth interior. Let us see what is a liquid dominated or a wet steam geothermal system. In a high temperature at around 175 degrees centigrade, at a high pressure, it will remain in a liquid state. When water is brought to the surface and pressure is reduced, rapid boiling occurs and it flashes into steam and hot water. The steam is separated and used to generate electric power in the usual manner. The remaining highly saline water can be used for direct heat and then re-injected into the ground. So here we are going to separate from the hot water which is coming either in the form of steam or a hot water. So that is not there in the earlier one. So here you can see from the sketch, right, the water from the reservoir has come, and here it is a separator, right? So only the steam is allowed to send to the steam turbine. ST stands for the steam turbine. The in the separator, if it is hot water, it is once again spent into, or it is sent to the well, right? And here as you see the steam, it is after working, since it is coupled with the alternator, this stands for the alternator, and this steam is being direct contact condense, it is sent to the direct contact condenser like a deaerator, and after that it changes phase and it is condensate pump is used, because condensate pump is something uh, which can be making the water available once again to the system, right? It has been condensate pump, here goes to the cooling tower, and here the hotness, it is a sink, right, where it rejects the hotness to the atmosphere, and the cold water or the condensate can be taken once again into the dumped into the system. In the TS diagram you can see here, this is the region where you have the saturated steam, right? So 1 to 2 is shown over here, and 3 is a separator. From the 3 separator, if it is the steam which is dry at the 4, which has been sent to the steam turbine, and it expansion takes place in the steam turbine, and it will be at the state either 6, and in the actual state it will be in a 6, and theoretically it may be 6 dash. Then it has been taken or in a condenser, or right, it will be taken into liquid form. Once again it is pumped into the state of 5, and accordingly the cycle is done. Hot dry rock resources. Let us see what is meant by hot dry rock resources. The rocks are impermeable and there is no surface water in. Underground water, generally temperature exceeds 200 degrees centigrade, with a little or no water are preferred. Man-made reservoir by drilling deep into hot rock and then cracking it from cavity or fractures. These are also called as EGS, enhanced geothermal system, or engineered geothermal system. These are achieved by detonating high explosion, nuclear explosion, hydraulic fracture. Out of the above, conventional explosive required would be uneconomically large. Nuclear explosion are associated with the safety. So here you can see the sketch how the hot dry rock power generation are used. So in the dry rock power generation, when you take right from this one, the dry rock, the steam is coming in the from the this one. It is in a impermeable surfaces. From there, when the fluid comes, and it is in the form, right, we are going to inject the water, and it turns into, right, it is because very hot, we are supposed to inject the water, and this water when comes out, it is in the form of steam, and this from this steam we are going to run this steam turbine, right? And once the steam turbine runs, surely it has to be coupled with the alternator, and after working it will be cooled down and once again injected to the hot water. This is, it is not only that, some areas where in the caves and all, right, if you have the it is used for making some other application, and that caves are not used now, we can use these caves for the storage, right, for the energy storage, and that may be a part of a dry rock power generation. Thank you.